Today, we will be looking at the effects of steady-state exercise on the body systems. To begin, steady-state exercise is pretty straightforward and is exercising at a constant pace for a period of time. A more technical definition is when the lactic acid removal is occurring at the same pace as the lactic acid production. Some examples of steady-state exercise is running or aquarobics. You can click on this link to view a video. In this video, we will look at the effects of steady-state exercise on 4 body systems. The first one is the cardiovascular system. There are quite a few things that happen to this body system that affect us. First, we have an increase in heart rate. As you probably know, when we start to exercise, our heart rate will increase. It will continue to increase until we reach the requirements of our workout and then plateau or flatten out because we are working at a constant pace. Let's look at this graph. First, we can see a slight increase in our heart rate and then it flattens out. We will also have an increase in our stroke volume. From previous lessons, we know that this is the amount of blood volume pumped during a heartbeat. This happens because we have an increased venous return. This is increased blood volume that stretches the cardiac muscles. The stretching makes the heart contract more forcibly, causing more blood to be pumped during each contraction, which increases stroke volume. This is known as Starling's law. We will also have an increase in our cardiac output. This is the amount of blood pumped in 1 minute. Due to an increase in our heart rate and stroke volume, we also get an increase in our cardiac output because more blood is required to supply oxygen to the muscles in action. Our heart is beating harder and faster. Thermoregulation. This is the body's ability to maintain a constant temperature. A few minutes into our exercise, our body starts to get hot, and the cardiovascular systems help us to get rid of that excess heat. The heat is lost through sweating and dilation of the blood vessels, known as vasodilation. As sweat evaporates from the skin, it also cools down the blood as it travels through the vessels close to the skin. Vasoconstriction also takes place around the organs so that more blood can be sent to the muscles. Lastly, we have an increase in blood pressure. The systolic pressure will increase because heart increases the force of its beats and the amount of pressure it exerts. Our diastolic pressure stays the same because the recovery pressure of the heart after it contracts stays the same. The second system we will look at is the respiratory system. There are 3 responses that happen to this body system that affect us. The first is an increase in breathing rate or breathing frequency. This increases to meet the demands of exercise to remove carbon dioxide in the body and supply the muscles with oxygen. Looking at the graph, it peaks for the first few minutes and then levels out to remain the same throughout exercise. The second response is an increase in tidal volume. This is the amount of air you can take in one inhalation. Our tidal volume increases because this is an increase in the depth of breath. We are essentially taking in bigger breaths of oxygen. And lastly, our oxygen uptake. This can be shown on the oxygen dissociation curve, which is a graph that shows the percentage saturation of hemoglobin and variable partial pressures of oxygen. Oxygen binds to hemoglobin from places with high oxygen and brings it to the muscle cells that have a low concentration of oxygen. Our CO2 levels and our pH levels can shift this curve either to the right or the left, which is known as the Bohr effect. Our blood becomes acidic when there is too much oxygen, which means there is a decrease in pH shifts. This shifts the curve to the right. In the lungs, there is a low pressure of carbon dioxide and low pH levels, would shift the curve to the left to enhance oxygen uptake. Our temperature also affects our oxygen uptake. If our body increases temperature, it shifts the curves to the right, and if the temperature decreases, it shifts the curve to the left. The third body system is the neuromuscular system. There are two things that happen to our neuromuscular system that affect us. The first is pliability or flexibility. As we start to exercise, our body starts to get warm, and so do our muscles. This allows us to become more pliable or flexible. Here we can see this girl is not as flexible before exercise, but after exercise, as our muscles get warm, you can see she's more flexible. This happens to prevent injury, such as pulling muscles. We also get an increase of neural transmission. As muscles warm up, the rate of the nervous impulse increases as the heat increases the speed of the transmission. This means that our reaction times will get faster. The last body system is our energy system. Our aerobic system is responsible for producing most of the energy supplied to our body, known as ATP. It is done through a process called aerobic glycolysis. Here we can see it on the PowerPoint. Glucose is broken down with the presence of oxygen and turns into pyruvate. Due to the presence of oxygen, this enters a series of reactions called the Krebs cycle. Pyruvate combines with the coenzyme A to form acetyl-CoA, producing ATP, hydrogen, and carbon dioxide. The hydrogen atoms from the Krebs cycle enter the electron transport chain, which combined with oxygen produces a lot of ATP, helping us to perform low-intensity exercise, such as running for 30 minutes. This cycle happens in the mitochondria of cells. The large folds, known as cristae, create a large surface for ATP production.